Next, we're going to take a look at Newton's law of cooling, and this just tells us how things cool down, or even, if you can kind of go the other way, heat up in some type of atmosphere. And so how this works is the rate of change in the temperature of an object is proportional to the difference between the temperature of the object and the temperature of the surrounding medium. And so we're going to take a look at, there's a room is kept at a constant temperature of 60 degrees, and a pizza is cooled from 100 degrees to 90 degrees in 10 minutes. And so they don't come right out and tell us these things, but we kind of know a couple of things. We got some initial conditions. We know that T of 0 is 100 degrees. That's like this. So they take the pizza out of the oven. It's 100 degrees, and I don't think it says Celsius or Fahrenheit, but that's 100 degrees is not very hot coming out of an oven, so it's probably got to be centigrade. And then we know after 10 minutes, so T of 10 is equal to 90 minutes. So it's cooled down. It's gone from 100 degrees to 90 degrees in 10 minutes. And so they tell us it's proportional. And so we need to find a formula for the temperature of the pizza at time t. And we're doing differential equations. So this is a rate, dt. And this is maybe going to be a little bit confusing. It's d of big T for the temperature over d of little t. And this is going to equal k, our constant of proportionality. And so T minus 60, right? And so it's the temperature T, big T is the object, and the 60 is the temperature of the surrounding medium. And so we're just going to work our way through and solve this. We're going to separate this differential equation out, and we're going to get d of big T over big T minus 60 is equal to k dt, and we're going to integrate this. So the left side integrates pretty easily. We don't have to worry about a negative sign. So this just becomes, the natural log of the absolute value of t minus 60. And this is equal to kt plus c, that constant of integration. And so we need to undo the natural log. So we're going to exponentiate both sides by e. And once we do that, we have t minus 60 is equal to, and remember, when we exponentiate this, this is going to become c e to the kt. And so we want to use this initial condition that they gave us up here. They told us that the temperature goes from, at time t equals 0, the temperature is 100 degrees. And so that's what we're going to use to start with. We're going to plug in 100 for t, minus 60 is equal to CE. It doesn't matter what k is because t is 0, so this becomes c to the 0. And we end up with c to the 0 is 1. C is equal to 40 degrees, or 40. So that's our first equation. We've solved for c. We need to rewrite this. So we have t minus 60 is equal to, and instead of, so right here, that's kind of where we substituted our c value in. We're going to plug in that 40, and so we have 40 times e to the kt. And from there, we want to solve for that k, that constant of proportionality. So we're going to use our second condition that they gave us. When t is 10, when time is 10, our temperature is 90 degrees. And so we're going to plug that in right now. So 90 minus 60 is equal to 40 times e raised to the, so I'm going to write it as 10k. And then we're just going to solve. 90 minus 60 would be 30, and then we're going to divide by 4, or 40, excuse me, and so that's going to be 3/4 is equal to e to the 10k. From there, again, we want to exponentiate both sides by, or we want to take the natural log of both sides, excuse me, and this is going to become the natural log of 3/4 is equal to 10k. Divide both sides by 10, and we get k is equal to the natural log of 3/4 over 10. You could write it as, if you wanted to, 1/10 times the natural log of 3/4. Those are the same things. And so that's what we've got. Let's write our final. So we have our equation. If we plug this back in, we get t minus 60 is equal to 40 times e to the, so this is my k, is 1/10 natural log of 3/4. Oops, let's try that again. Of 3/4 times t. But we haven't solved, so we need to add 60 to both sides and rewrite this finally as a function. So t of, this is maybe a little confusing, big T of little t is equal to 40 times e to the 1/10 natural log of 3/4 t, and then we added 60 plus 60, and that is our equation. And so that one's fairly straightforward. And I'm going to let you guys work on part B, and I'll help you set it up, right? So we want to know after how many minutes will the temperature of the pie be 80 degrees? And so that's our T of t. So we have 80 is equal to 40 times e to the 1/10 natural log of 3/4 t plus 60. And so we want to solve. I want you to pause the video and work on this. So hopefully you pause the video and we can work our way through and solve this. So we want to get 40e to the 1/10 raised to the 1/10 natural log of 3/4 t all by itself. So I'd subtract 60 from both sides. And so 80 minus 60 would be 20, and then I would divide both sides by 40. And so we're going to end up with 1/2 is equal to e to the 1/10 natural log of 3/4 times t. So we want to keep solving. We're going to take the natural log of both sides, and we're going to get the natural log of 1/2 is equal to 1/10 times the natural log of 3/4 t. We're solving for t, so kind of like our next step, right? Our next step, we're going to get t is equal to, I don't like that color. We're going to get t is equal to, so it's going to be the natural log of 1/2. I would multiply both sides by 10 and divide both sides by the natural log of 3/4. And so that's our exact answer. We like exact answers, but let's get an approximate answer. We can put this in our calculator and get an approximate value of 24.094 minutes. So after 24.094 minutes, the pizza has cooled down to 80 degrees.